Hi, in this video we will solve problem valid parenthesis asked by companies like Amazon, Microsoft, Facebook, Google and some others. Let's check out this problem statement valid parenthesis. Okay. Again one of the most famous quite fundamental problem. Okay. So let's check out given a string S containing the just the characters like this. Okay, these are all 6 characters basically open close brackets. Determine if the input string is valid or not, right? And how we will judge an input string is valid. Open bracket must be closed by the same type of the bracket, like if you are opening with this parenthesis, okay, curly braces, so it should be closed by this one only. Okay, this is not acceptable, like you are closing by this. Okay, open bracket must be closed in the correct order, right? So suppose if you have suppose this bracket, okay, and then you have this bracket, okay, but first close the first one. Now this is closed and this is how this bracket is closed, right? So in the order, right, it should be closed first, right? It should close first, then it should, then this bracket should be closed, right? So this is also not a correct order. Now every closed bracket has a corresponding open bracket of the same type, right? So if there is a closed bracket, right, it cannot be a single closed bracket only, right? There should be a corresponding open bracket of the same type, okay, of the same type in the correct order. So let's check out few examples here. Okay, so here you can see one open bracket and one closing bracket, and both are quite same. This is quite closed here, so that's why the output is true. Here you can see, okay, one open, one close, then one open, one close, then one open, one and close, right? All the three types have covered and all the three types were closed. Like when once it open then it is closed, right? So here also the output is true. Then here you can see, here it is open but it is closed by a different type of a bracket, right? So here the output will be false. Okay, so now let's check out few more examples to understand this better. So suppose I have one string s something like this, with this bracket and with new open bracket, then close bracket, curly bracket, and then this bracket, we have this one and we have this one. So is it a valid string? Is it a valid parenthesis? So let's see. So here we have one open bracket, okay, then we have one curly open bracket, okay, then the first curly bracket is getting closed, then again one open bracket, curve open bracket, then curve open bracket is getting closed, and then we are closing this one. That is also acceptable, right? Because mm, the first one that open, like the last one that is open, and it is closing first. And here you can see one open, one closed. So yes, that's a valid parenthesis. Okay, and let's see few more example. So let's suppose if my string is starting with a close bracket, okay, and the string is something like this. What do you think? Is it a valid? No, because it is starting with a close bracket, right? The initial bracket is there should be a open bracket then closed one, right? It should not be start with a closed bracket, right? So from here itself, I can say that this is not a valid parenthesis, right? Okay, and then let's take few more example. Suppose you have one open bracket, curly open bracket, then you have like this, then you have this, and then we have this one, and we have this one, something like this. So, so here let's modify a bit. Instead of this one, let me put this curve bracket. So you can see, if you check the complete string, so we have a equal amount of closing and opening brackets. So like this is open, this is got closed, this is open, this is got closed, this is open, this is also got closed, right? So we have like equal number of opening and closing bracket, okay, but the order is not equal, like, so let's see one by one. So this is open, right? Then this bracket, square bracket is open, and now the curve bracket is getting closed first. This is an issue, okay. The bracket that is last open, again I am repeating, the bracket that is last open, it should be closed first, okay. So suppose you have this bracket, this and this, so the first one should be closed, that the square bracket, and then you need to close this one, then you need to close this one, okay. Suppose something is like this, so you can't close it this one, right? It should, like, this is open in the first number, this is open in the second number, this is open in the third number, this is open in the fourth and fifth. So the last bracket that is open, it should be closed first, right? So fifth one closed first, then the fourth one will closed, then the third one will closed, and then the second one. This is not so. I will add one more curve bracket, okay, and then there should be a curly bracket in the last. So we you can say that there is a one very unique property that I am applying here, that the last bracket that is opening, or I can say it as last open bracket, should should get closed first. Okay. So again, this is not a valid parenthesis. Okay. Okay. Now we are applying this property, last open bracket should get closed first, right? This is quite similar to last in first out, right? If you have studied this, that is one methodology, you can say, or one principle. The If I am taking service, okay, or if I am opening browsers, okay, so the thing that I have put last will be the first one to come out. So you can understand by the example of a stack of books, right? So in books, if I am putting one over the other, like suppose if I placed one book, okay, on the top of it I placed one more book, on the top of it I placed one more book, on the top of it I placed one book. So the last book that I have placed will be the first one to come out, right? This is how I will extract. You can also understand by the stack of chairs. So all these are examples of this principle, last in first out. A stack of books, okay, stacks of chair. So in marriages, you can understand, right? There is a stack of chairs, okay? Complete chairs from bottom to top, okay? And the first chair that will come out will be the last one that is placed, okay? So yes, we are getting a last in first out of this methodology here, and we will apply the same, right? So we will use stack data structure here because that is resembles with the last in first out principle, right? So we will use stack data structure here because this contains the property of last in first out. Okay. So now let's see how we will solve this problem, how we can solve this problem by using stack data structure. So, so let me take one string here, like the same example, one square bracket, then this is the one square bracket, then one curly bracket, and then the curly bracket is getting closed first, and then we have one curve bracket open and close, and then I'm closing this bracket, and then one again curly bracket open and close, right? So this is one example, and let's see how we are applying stack data structure. So let's see, this is my stack. So let me mention that this is my stack and how we will use it. So let me add the indexes for better understanding because this is the string. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is a string, and let me write down the few steps. So what is the size of my string? So that is 8, and these are the indexes. Let's start. So what I will do, I will simply start from here, the 0th index, and I will move in this direction one by one. So let's take the first bracket. So what I will do, I will check it, I will classify the brackets in two parts. Okay, I will first find out open and close bracket. Okay, is it an open bracket or closed bracket? So all are my open brackets will be like this one. This is one open bracket. Then we have, this is one curly open bracket. Then we have, this is one curve open bracket, right? So I will find out what are my open brackets. Here also let me mention the close brackets. These are my close bracket, and this one. Okay, so first I will check, is it the open bracket or a close bracket? So open bracket, right? So what I will do, I will push into the stack. So I will simply push into my stack here. Then I will move. Then I will again check, is it an open bracket? Yes it is. So what I will do, I will push into my stack. Then again I will check, is it the open bracket? No. So when it is not an open bracket, what I will do, I will I will find out the what is my top of the stack, right? What is at the top of my stack, right? And this is the bracket that is top on the stack, right? So I will simply pull out that the top of the bracket is this one, and my current bracket, right? My current bracket is this one. Are, this is a like form of a closed bracket. Yes, this is of same type. This is of same type, right? So what I will do, once I am getting a complete closed bracket. So what I will, let me explain it again. This is my current bracket, current string, you can say current bracket, and from here I am getting this as an open bracket, and this is a perfect type. Okay, this is open and this is closed, right? So what I will do, I will say yes, these are matching, and I will pop out my element from the stack. So what I will do, I will pop out my element from the stack. Now my top will shift from here to here, and I will simply move. I will simply move. So I will move from here. Again one open bracket. So what I will do, I will push into the stack, and my top will shift to here. Okay. Now again one close call, right? One close bracket. So I will mention it here. This is my close bracket, and I will find out what is my top of the stack. Okay, so this is the open bracket, and both are of the same type. Both are of the same type. So what I will do, I will simply pop out from my stack, and I will move. So this will be my top, and I will move it. Now I am getting one again close bracket, right? Close bracket. So what I will do, I will simply check, this is my current close bracket, what is in the top of the stack? So that is one, this bracket, and both are of the same type, right? Both are of the same type. So what I will do, again I will pop out from the stack, and I will move. Again one open bracket, so I will push into the stack. Okay, now I am getting one closed bracket. So again what I will do, I will check, this is my closed bracket, what is my top of the stack? This is the bracket, both are of the same type. So what I will do, I will pop out the bracket. So now in the last, you can see my stack is empty, right? My stack is completely empty. So I can say that there is no unbalanced string, right? There is no unbalanced bracket. Okay, so by the stack is empty, I can simply say that there is no unbalanced bracket. When there is no unbalanced bracket, I can simply say that this is balanced, and I will simply return true here. Okay, now let's check out the another example where we can understand more better. So now let's see this example. Here I have taken the exact same example, but I have added few more open brackets in the last. And now let's quickly understand. So let's quickly move it, because we have already understood how this is working. So we have one open bracket, I will simply push into my stack, and I will move. Again one open bracket, I will push into my stack, and I will move. Okay. Now I'm getting close bracket. So this is my current close bracket. I will check which is my top of the stack. Okay, this is of the same type. Yes, what I will do, I will pop out and I will move. So I will pop the bracket and I will again one open bracket. I will push into the stack. Okay, one close bracket. I will check. This is my current close bracket. What is top of the stack? Okay, this is my bracket. Both are of the same type. So I will simply move and I will pop out and I will move. So pop out and move. Now again one close bracket. So this is my current close bracket. What is my top of the stack? This is my top of the stack. Both are of the same type. So what I will do, I will simply pop out and I will move. Open bracket, I will push it. Again one open bracket, I will push it, and one close bracket. So I will check. Okay, what is my top of the stack? This is the bracket, top of the stack. I will compare. Yes, they are of the same type. I will pop out from the stack and I will move. Now after, you can see, after completing all the iterations, still my stack is not empty, right? My stack is not empty here. So I can say that the brackets are not balanced, right? So here the brackets are not balanced, and that's why the result will be false. Okay, let's check one more example when we have equal amount of brackets but in a different order, right? So let's see. So let's see this bracket. So we have one open bracket. I will simply move it. Okay, and again one open bracket. So I will simply push into the stack. Okay, so whenever there is an open, I will push into the stack. And now I am getting a closed bracket. So I will compare my current closed bracket. Okay, what is in my top of the stack? Okay, this is the bracket that is top on the stack, and these are not of the same type, right? Not of same type. So what I will do, I will simply directly say that here return false, that these will be unbalanced, right? So the bracket that is last open should be closed first, right? So this is the last open, right? This is the last open that is in the top of the stack. So this should be the first, and there should be the first closed bracket of this type. Okay, that's why the result will be false. Now how we are going to solve this? So what I will do here, how we will write the logic. So let's suppose I will start with one single iteration for loop. Okay, I will start from 0 to n. Okay, or I'm covering all the brackets. Now inside it, if I am getting that my the element is open bracket, right? So I can mention s of I. Is it if it is like this one, or if this character is like this in one, this is the one also open, or if it is like this one, mm, this one. So all these are open brackets. So if this is the case, what I will do, I will simply push into the stack. So I will simply say stack dot push the element s of I. Okay, and in the else part, right? So this is one when these are all are open. In the else part, what I will do, I will again check few things. So first of all, in the else part, if I am getting my stack is empty here, that should not be empty, right? If the stack is empty, I will simply say that return false, because it should not be empty. Okay, and I will simply mention if this is not the case, else if what can be that your current element is, suppose your, you can say that s of I is equals to like this one. Okay, but your top element, right? Now I will say that stack dot peep. So stack dot peak. Okay, that is your peak element, the topmost element, right? Your peak element is not equals to this one, not equals to this one, right? It should be like this. So if it is not equals to this one, what you will do, you will simply return false. So this is one case, right? Similarly, or when I can return false, when s of I is equals to, so if we have, suppose this is as a close bracket and condition stack dot peak, simply if it is not equals to this bracket, then I will also say that return false. Or if I have this as a closing bracket and stack dot peak is not equals to this one, so then also I will simply say return false. So in all these cases I will return false. Else in the last, okay, let me mention it here. In the last, if it is not the case, that means these are matching. So what I will do, I will simply do stack dot pop, okay, if it is come to this case. And yeah, if in the last what I will do, I will check if my stack dot like stack is empty. If my stack is empty, right, then I will say yes, that I need to return true. Otherwise, if it is not empty, I can return here as false. Okay. So this is how we can, and we can simply write the code of it. And what will the time complexity of this one? So simply we are starting from 0 to n. So here the time complexity is depending on the size of the input string, and we have only if else condition, right? So even if we are doing multiple pops push, it will be remain same. So the time complexity will be big O of n. But for space we are taking one extra space, that is we are using stack data structure here. Okay, and the stack can have the all number of open brackets. Suppose you have a complete string of all open brackets, so it will have all open brackets up to size n. So the in worst case the space complexity will be big O of n. Okay, so now in the next part of the video we will see the code implementation of this problem statement. Okay.